This webcast is going to overview some features of the ComRaider tool, which will soon be available on the labs.idefense.com website. ComRaider is a tool that has been designed for auditing COM interfaces. It's a basic COM interface fuzzer. So what we're going to do is we're going to start. Here's our main load file. This is our wizard form. We have several different options on how to load up files, back-to-back servers, or FUD scripts that have already been generated. Here for the demo, we're going to load up a vulnerable ActiveX server that comes full source with ComRaider. So this is included in the install directory, and we will select it. It'll load it up. This is the type library viewer form. What this does is it will read the type library that's been compiled into the ActiveX server. Had a type library not been provided, then it can also try to create an instance in memory and query the iDispatch to get a listing of all the methods and their prototypes. So what this is here's the library, the class, the interface, all of its methods. Each one of these has a context-sensitive menu, right-click menu, and a custom information that'll show up over here in the display pane. If we click on the class, we can see some of the flags. We can see what its default interface is. We can see if it's been marked in the registry as safe for scripting or safe for initialization. We can also view an object safety report. Had this implemented iObject safety interface, and the flags would have been defined whether it supports an untrusted caller or untrusted data and what interfaces it does that on. So what we'll do is here we'll click on the method. We get prototypes if we click on any of these. We'll fuzz this specific number. Here we generated 5 configuration files, 5 test scripts for this one function. We'll click next to go to the debugger pane. Had this object needed some kind of initialization, like a record set loading data from the file, then you could have included a custom script prolog that would have been included on each of these script files. In this case, we don't need that, so we can go ahead and move over to the debugger pane. So this is our main list view. This lists all of the files. It will list the exceptions and windows and the results. This has a large right-click menu. This view, the second list view down, is going to cover all of our captured exceptions. The third one down, this includes a basic window monitor that will take any script errors, any modal message boxes. It will record the data that they're going to present and close them automatically. And it will also include an API log if the option has been set for using an API logger, and you can filter these results with a comma delimited string here. So what we'll do is we'll start our debugger. It's going to cycle through all the files that have been loaded into this. I can see it beginning. It's already caught an exception. I'll stop it after a second. We'll get a couple more here. I can stop it. You can see that there were 2 windows, 3 exceptions. We can see that our list has been trimmed. This is because our delete duds option is on and the save only exceptions. That will trim out our list and delete all the unused files for us. So what we'll do is we'll click on one of these. We can see that this script here through 2 different errors, a breakpoint and that access violation. We can view the actual script's text by right-clicking and go to View File. We can see that some other custom information has been embedded in there. We can see the function prototype. So what we'll do is click on one of these, say we wanted more information about the exception environment that this breakpoint was triggered in. We can either double-click on it or go to View Details, and we can see all of the customer information that is extracted for us. We can see the SEH chain. We can see one of the pointers was overwritten. We can see the call stack, again, one of the return addresses. Here is a register dump, and we can see that this was a data offset, and from there we were able to extract this ASCII string. It also extracts pointers and can view reference those. Here is a block disassembly. Here's where our crash actually happened. And so we disassembled back a ways and we disassembled forward so that you can get some idea of what's in there. This isn't meant to be in the most comprehensive report, but it is hopefully enough information to give you an idea whether you need to probe this further or if it was just something that was not exploitable. If you wanted to dig a little more, if you were curious if this could be launched in a web browser or if it was an unhandled error, you've actually test the exploit in IE, in which case the XML is going to be converted into HTML, put into a custom web server that's included with the package. In this case, we can see that this control has not been marked as safe for scripting, and Internet Explorer will not load it, which is good. It's good information to have. We can also launch the file normally under WScript without the debugger attached, or we can launch it in our debugger of choice, which has also been set in our options pane. These two options are related to the distributed auditing, which has already been set up in this client for us. There will be more information in the help file on how to set that up. We can upload this individual file to our distributed database. We can see that it's been uploaded. It will also, if you're in distributed mode, it will also try to upload every class that you've audited so that everybody can keep track of it. You can edit his notes. So what you do is, now if you wanted to access, this part is going to relate to the distributed mode. Here we can click on some of the other options. We can see a distributed notes where everybody can share their data, share ideas on audit targets, things of that nature. Here we can look at our audit logs. We can see all of the logs, all of the objects that have been audited by class ID, user, date, the number of tests run. We can search it based on all of these criteria. And we can also, here we'll go to the view shared files from distributed audits. What this is the way I just uploaded that one file to the central server. Now it's available to everybody. And the information that has been uploaded includes the date, the name, the class ID, a number of exceptions, and all of the environment that was captured. So we could, again, be the exception details, and now anybody can look at all this without even having to rerun the test. Had they wanted to rerun the test, they can multi-select several of those. They can choose to either view the type library for the file, or they can choose to download and fuzz it, in which case these two files will be dropped, will be created on disk, and put right into the debugging pane so that another analyst could take a look at them in a live environment. Some of the other features that we have here are we can choose from controls that should be loadable in IE. So what we'll do is, this is the first time it has been run. Right now it's under default options, so it's going to go through registry scanning mode. We will build this database. We can see that it found 4,000 class IDs relating to COM objects, and right now it's scanning them all. We see that it found 156 that have been marked as safe for scripting or safe for initialization based on registry keys. Now this list is not completely comprehensive. These are all the ones that have implemented categories as safe for scripting. As you click on each of these, it will give you some information on each of them. When you hit select, it will bring you into the type library viewer. Now what this is we can see up here only showing a certain class IV. If we click on the library, we can see that this library actually contains 2 classes. Had we wanted to see everything that's in this DLL file, we could go to show all classes, in which case it will load all of the elements for us. Now, by default, this only shows the fuzzable objects, the fuzzable methods. Now we can see that these are not highlighted. In these cases, these are property let Boolean values. There's only 2 possible values for a Boolean, so there's not really much sense in trying to fuzz it. So it's been marked as non-fuzzable. Some of the other things that we can do is, if this had not been anything of interest, we could say mark it as audited, in which case it'll update our central database. It'll mark it green for us so that we know. Every time this form has loaded, it will download all of the audit logs from the central server, and it will see if any of these had been audited. If they have, it'll turn them green. When you click on it, you can see that the fuzzing test down here. Again, you can see the object safety report by clicking on it. In this case, none of these have supported the iObject safety. I'll see if I can find one that does. I might bet it did. But by default, this will scan all of the registry keys. There's also another method that's a little bit more comprehensive. If we go into our actions and we unclick the scan registry only for safe objects, then what will happen is it will run an external application. It will try to create, it will enumerate all of the classes that have all the COM objects on the system. It will try to create a live instance of each of those objects and query it for the iObject safety interface. And you should get substantially more numbers of auditable COM objects by doing that. However, it is a long process, and you're going to have to close windows that open, so that's not the default. But you're more than welcome to try that and dig through its results. Those represent all of the major features. You can also scan certain directories and try to find all of the files below it. You can load previously generated fuzz files. You can try to load it based off of it, the class ID or GUID. Let's see. The offline audits option is in case you're working on the road and you've set up your distributed auditing to save to the local access database instead of an external database server that the team may be sharing. Those are all the major features for ComRaider. There's a lot of involved behaviors, and it's going to take a while to get used to, understanding how everything works. But it's proven to be a pretty decent tool, and I think you guys will get a lot of good use out of it. Enjoy. Thanks.